Hey everyone, welcome back to Deep Dive. You know how we're always saying there's more to learn? Well, get this. Scientists have figured out how to slow down light.
Yeah.
Light?
Yeah.
The stuff that zooms through space at what, 300,000 kilometers per second?
Yeah, it's fast.
They've slowed it down to the speed of a car.
It's wild. They've even figured out how to stop it completely.
Stop it!
Yeah, like hitting the pause button on the fastest thing in the universe.
Okay, I am hooked. But how is that even possible?
Well, to understand that, you have to delve into the world of quantum mechanics.
Okay.
Specifically something called a Bose-Einstein condensate, or BEC for short.
Okay, a Bose-Einstein condensate?
BEC.
That sounds kind of intimidating.
It's a mouthful.
Can you break it down for me?
So imagine cooling a gas down to almost absolute zero.
Okay.
At this unbelievably low temperature, the atoms in the gas start acting like one giant unified wave.
Wow.
They lose their individual identities, and they behave as a single entity. It's like a bunch of individual singers suddenly becoming a perfectly synchronized choir.
Oh, so it's like a superatom.
Yeah, that's a good way to put it.
Okay.
And this superatom has some really unique optical properties.
Right.
It's kind of like a special type of medium that light interacts with in some really interesting ways.
Gotcha. So this BEC, it wasn't just like a random idea, right?
Right, you're right. It was actually first theorized by Albert Einstein
Oh, wow.
and Satyendranath Bose back in the 1920s. But here's the thing.
Okay.
It wasn't actually created in a lab until the 1990s.
Oh, wow. So this is pretty cutting edge science then.
Yeah, very much so.
And they're using this to mess with the speed of light. How does that even work?
So in a nutshell, they created a BEC using a cloud of ultra-cold sodium atoms. And then they shot laser beams through it.
And that's when things got weird.
Exactly. As the light passes through this BEC, it interacts strongly with those supercooled atoms.
Okay.
The photons, those tiny particles that make up light,
Right.
they get absorbed and re-emitted by the BEC atoms, causing them to slow down drastically. You can almost picture it as the light trying to move through thick molasses.
So instead of zipping along at its usual, breakneck speed, it's crawling along.
Precisely. And we're not just talking a little slowdown. Researchers have managed to slow light down to a mere 17 meters per second.
Wait, 17 meters per second? That's what, 38 miles per hour?
Pretty much, yeah. It's mind-blowing to think that we can take something that's supposed to be the fastest thing in the universe and slow it down to the speed of a bicycle.
That is wild. And you said they even managed to stop light completely.
Yes.
How is that even possible?
It's remarkable, isn't it? By carefully manipulating the BEC and the laser beams, they were able to essentially trap the light within the BEC,
Wow.
holding it still for a fraction of a second before releasing it.
Okay, so now I have even more questions if we can trap light like that.
Yeah.
What does it actually mean? What are we looking at here? Is this just some cool science trick, or does it have actual applications?
That's where things get really interesting. It's not just about scientific curiosity.
Right.
It's about potentially revolutionizing the way we live, work, and understand the universe.
Okay.
Think about it this way. Light carries information.
Okay.
Every email you send, every website you visit, every photo you take, it's all based on light.
Right.
Specifically manipulating and transmitting photons.
Okay, so by controlling light, we're essentially controlling information.
Precisely. And being able to slow it down and even stop it opens up some incredible possibilities.
Like what?
Particularly in computing.
Ah, you're talking about those super fast computers we hear so much about, right? The quantum computers?
Exactly. Quantum computers rely on the principles of quantum mechanics to perform calculations far beyond the capabilities of our current computers.
Right.
And guess what plays a crucial role in quantum computing?
What's that?
Light, or more specifically, photons.
Okay, so instead of electrons moving through circuits like in our regular computers, quantum computers would use photons. And because we can now manipulate the speed of light, we could have lightning-fast processing speeds.
Imagine a world where complex calculations that currently take years could be done in seconds.
Oh, wow.
Drug discovery materials, science, financial modeling, artificial intelligence.
Yeah.
All of these fields would be revolutionized.
That's pretty mind-blowing.
Yeah.
What about something a little closer to home?
Yeah.
Would this impact our everyday tech?
Absolutely.
Like our phones and our laptops?
Think about data storage.
Okay.
Right now, we rely on magnetic hard drives or solid-state drives.
Right.
They're fast. But imagine storing data using light.
Okay.
We could create optical memory systems that are thousands of times faster than anything we have today. Your phone could hold a lifetime of photos, videos, and data.
Wow.
All accessible in an instant.
That's amazing. And I remember you mentioning unhackable communication networks earlier.
Yes.
How does slowing or stopping light help with that?
This is where things get really interesting on the security front.
Yeah.
In the quantum world, the very act of observing a photon changes its state. This
Mm-hmm.
principle can be used to create incredibly secure communication channels. Imagine sending a message encoded in photons.
Okay.
If anyone tries to intercept or eavesdrop on that message,
Right.
they'll inevitably alter the photons, immediately alerting both the sender and the receiver that there's been a breach.
So it's like having a built-in alarm system for your data.
Precisely. And because this security is based on the fundamental laws of quantum mechanics, it would be virtually unbreakable. No more worries about hackers stealing your personal information or sensitive data.
Oh, wow. Okay, so far, we've talked about how controlling the speed of light could lead to super fast computers, incredibly dense data storage, and unhackable communication networks.
It's amazing.
But I can't help but wonder, does this also change how we understand the universe itself?
Hmm.
I mean, light and its speed are kind of fundamental to physics, right?
You're hitting on a really important point. For centuries, we've understood the universe through the lens of Einstein's theory of relativity. And one of the cornerstones of that theory is that the speed of light in a vacuum is constant,
Right.
the ultimate speed limit.
But now we're messing with that speed limit. Did that mean Einstein was wrong?
Not necessarily. Einstein's theory still holds true. In most cases, what we're doing with these BECs is manipulating the way light interacts with matter. Think of it like this. You're driving on a highway,
Okay.
and the speed limit is 65 miles per hour. Now imagine encountering a section of the road that's covered in thick mud.
Okay.
Your car slows down, not because the speed limit has changed,
Right.
but because the conditions of the road have changed.
So we're not breaking the speed limit, we're just changing the terrain.
That's a great analogy, and by changing the terrain, so to speak, we're opening up new possibilities, new ways of understanding how light behaves and how we might harness its power.
So even if we're not breaking the speed of light, we are challenging our assumptions about its role in the universe.
Absolutely, and this has profound implications for our understanding of time and space. Remember, Einstein showed us that time and space are intertwined, that they're not absolute, but relative to the observer's motion.
Right.
And the speed of light is the key factor in this relationship.
So if we can manipulate the speed of light, does that mean we could, in theory, manipulate time and space?
It's a question that has scientists and philosophers buzzing.
Yeah.
Imagine being able to slow down time or even travel through. It sounds like science fiction, but who knows what the future holds.
This is getting pretty deep. I need a minute to wrap my head around all of this.
And we haven't even touched on the potential impact on our understanding of gravity
Oh, wow.
or the expansion of the universe.
Whoa, there's even more.
There's always more to explore.
Okay, I think I've caught my breath. So we've slowed it down, we've stopped it, we've talked about all these like mind-bending possibilities.
Yeah.
But what about the people behind all of this, who are the masterminds making this seemingly impossible science happen?
That's a great question. It's easy to get caught up in the what and the how and forget about the who behind every scientific breakthrough.
Right.
There's a team of dedicated individuals, often working for years, sometimes decades,
Yeah.
driven by curiosity and a passion to push the boundaries of human knowledge.
So who are these like light-bending pioneers? Where did all of this begin?
Well, you have to go back to the early 90s. Remember, BECs were purely theoretical
Right.
until a group of physicists at the University of Colorado at Boulder,
Okay.
they finally managed to create one in a lab.
Wow.
They used lasers and magnetic fields to trap and cool rubidium atoms to a fraction of a degree above absolute zero. It was a feat that earned them the Nobel Prize in Physics.
Wow. That's impressive. Talk about a light bulb moment, or should I say a BEC moment.
Right.
But how did we go from creating this supercooled state of matter to actually controlling the speed of light?
That's where another brilliant mind comes in, a physicist named Lin Hao at Harvard University.
Oh, yeah?
She and her team were the ones who figured out how to use a BEC to slow light down. First to 38 miles per hour, and then incredibly to a complete standstill.
It's amazing to think that just a few decades ago, this was all science fiction. Now it's reality.
And that's the beauty of science, isn't it? It's a constantly evolving story. What seems impossible today could become commonplace tomorrow.
This has been such an incredible journey, and I feel like we've only just scratched the surface.
We have, and that's what's so exciting. This is just the beginning of a whole new era of scientific exploration.
So where do we go from here? What's next for the future of light manipulation?
Well, for one, researchers are working on creating more stable and efficient BECs,
Okay.
making them easier to work with. That's going to open up even more possibilities for controlling light. And then there's the exploration of new materials.
Okay.
Sodium and rubidium were just the starting points. Imagine what we could achieve with different atoms and molecules.
So we could be talking even slower light speeds, or maybe even faster than light travel.
Now, faster than light travel is still firmly in the realm of science fiction, but you never know. We've already broken barriers we once thought unbreakable.
That's true. What other scientific truths might be overturned in the future?
Exactly. It makes you realize how much we still don't know.
Well, I think we've covered a lot of ground here today. We've gone from supercooled atoms to the potential for time travel and everything in between. But before we go, I want to bring it back to you, our listener.
I agree. What are your takeaways from this deep dive?
What surprised you? What excited you? What questions are still swirling in your mind? We'd love to hear from you in the comments.
And while you're there, don't forget to like and subscribe to Deep Dive for more mind-blowing explorations into the world around us.
We're always looking for new topics to explore, so feel free to suggest future deep dives in the comments as well.
Until next time, keep those brains buzzing and never stop questioning the world around you.
From all of us here at Deep Dive, thanks for listening.